All right, so let's go through a practice problem. So this is the exact practice problem that is found on the presentation slides right afterwards. Once again, it's the exact same process as how to figure out the chemical formula of a hydrated ionic compound. And so once again, there's the exact same three steps. And so let's write those steps out once again. So step one, our job is to find out how many moles of our ionic compound we have. And so we're trying to find out how many moles of magnesium chromate, so MgCrO4. So this is moles of MgCrO4 that we have based off of the information that's given. And so we are given a certain amount of grams. And so we are going from grams to moles. And so once again, what we do is divide by the molar mass. And that information is actually given to us, right? So the molar mass of this compound is given to us as 230.38 grams per mole. And so we're able to convert between those two things. And so let's set this thing up. Remember, our job is that we set this thing up as always like a dimensional analysis. And so we have 2.30 grams of our compound. And we use a ratio to get us to moles of our compound. And so we want to get moles of MgCrO4. And so the way we do this is by using the molar mass. And so remember, this could be written as two different ways. Either this is going to be written as 230.38 grams over 1 mole, or this could be written as 1 mole over 230.38 grams. And so our job is to figure out which one we're using. Remember, if we're going from grams, that is the unit we want at the bottom. Since we want moles, that is always the unit that we want on top. And so we use the ratio that has moles on top and grams on the bottom. So we have 1 mole over 230.38 grams on the bottom. Our G or grams units cancel each other out, and we're left with 230 divided, or 2.30 divided by 230.38. And this is equal to roughly 0.01 moles of MgCrO4. Step 2 is always the same, which is that we want to find out how many moles of H2O we have. And so this is by using the information that's given to us, which is the grams of H2O. And that's how we convert between these two things. And so we're going from grams to moles once again. And so this is by dividing by the molar mass. And so we need to know the molar mass of H2O. So let's write this over here. Molar mass. And that is going to be of H2O. That is going to be equal to 2 H's plus 1 O, or 1 oxygen. And so that is equal to 2 times H's value, which is 1.08 or 1.01, plus 1 times oxygen's value, which is 16.00, and this is equal to 18.02 grams per mole. If you wanted to memorize, this is always the molar mass of water, and so you could always just know it as 18.02 grams per mole. And so remember, this could be written as two different ways, and it's dependent on what we have to do here. And so we have 0.90 grams of H2O, right? So that's the given information. We're trying to go from that to moles of H2O. And so once again, we use a ratio. Grams is what we want at the bottom. Moles is the unit we want on top. And so remember, molar mass can be written as two different ways, whether that be 18.02 grams over 1 mole, or 1 mole over 18.02 grams. And in this case, we want to use the second one, right? Because we want moles on top. So it'll be 1 mole over 18.02 grams. So our grams cancel each other out. And this is equal to 0.05 moles of H2O. And then our last step is to always, step 3, is to find the ratio between our ionic compounds. That'll be MgCrO4 to H2O. And so we know that we have 0.1 moles of MgCrO4, and we have 0.05 moles of H2O. And so we know the ratio is 0.01 to 0.05. And so our job is to find a whole number ratio between these two things. The easiest thing to do is you find whichever one is smaller. So 0.01 is smaller, and you divide both of these numbers by that. And so we divide this by 0.01 and divide this by 0.01. And this is equal to 1. And this is equal to 5, right? And so we know our ratio between our compound is 1 to 5. And so that is exactly what we write in our chemical formula. And so this would be MgCrO4 dot 5 H2O. And that is our chemical formula for this ionic compound or hydrated ionic compound, specifically hydrated magnesium chromate.